right, so I'm going to introduce the teams here. The first presentation is I-Guided Servo System, EGSS. So, is that right? Yes.
Good afternoon, and we are the I-Guided Servo System, or EGSS for short, group. My name is Masood Zareh, this is Tim Abraham, Jonathan Davin, and Lance Handel, and we are all electrical engineering majors, and that is Jerry Layton, who is a CE and ME double major. The reason we decided to take this project on was because we wanted to create a hands-free, I-guided or targeting system for EMTs, police officers, military personnel, or basically anyone who just wanted to have a hands-free tracking system using their eyes. The goal of this project was to design a system that would intake eye movements using a camera, and it would take the camera image, send it to a program that would correlate the eye movements to a set of coordinates that would be sent to a series of servos. The way we accomplished this was, you took a camera, which is the image of the eye, it would send the image of the eye into an I2C program, and it would use the Raspberry Pi to process the image, which would invert it and take away any saturation, thus making it a black and white image. If the program had worked correctly, which it does, you'll see white bulbs of people. The white people will be tracked, and those coordinates would be sent to, would be translated to PWM signal, which would be sent to a servo driver. The servo driver, which also powers the servos themselves, would send the PWM signals straight to the servos themselves, and it would move according to your eye movement, left, right, up and down, in diagonal. We hope in the future to be able to create a focusing system or add an IR camera, or basically, and make it much more mobile, because right now it's on a harness and you have to keep the camera right up to your eye. The way we accomplished this project was that Tim, Jonathan, and Lance were in charge of creating the prototype and the final harness product. Jerry was the main programmer, and I assisted him with some of the programming. Jonathan and I were also creating a prototype servo driver using a chip that we found online. However, we realized that Atrium actually sells a manufactured one, so we ended up scrapping the prototype and using the manufactured one. If there's any, that was our presentation. If there's any questions, I'll take.
So, could you say what was the design criteria that you were trying to achieve for senior design one?
Oh, we were actually we wanted to make sure that the eye was tracked using the camera, and that the servos were moving in correlation with the eye, and we actually have accomplished that. And there is a demo set in our booth for today.
So, was there a percent accuracy that you had to be able to achieve for the tracking?
Right now, we're hoping for 30% accuracy, but we don't have an actual, we don't have a very, we don't have a calibration system in place right now. We have a very simple one where we put the camera up to our eye, and we make sure the servos are starting at 90 degrees, which is the 0 point for the servos themselves.
Other questions?
Yes.
So you've got one more semester to go. What's your plan? What do you want to do in senior design 2?
For senior design 2, we're hoping to make it a much more mobile servo system, because as of right now, again, when you see it in the demo booth, you'll see that it's on a wooden harness, and the servos are moving up and down, left and right. We were hoping to, for senior design 2, to make it a mobile servo system where you can attach it to your shoulder or a helmet, so that way, depending on when your eyes are moving, the servos are really close to your eyes, so it'll move much more accurately with your eyes moving as well. Because right now it's just, right now we have the bones of it, and we're hoping to add some meat next semester.
You said infrared.
Oh, well, that wasn't it for second semester. We were hoping to do infrared because it could be for police officers who can, we would attach a peak projector to a set of goggles so they could see basically through walls, so you can see if there's any people behind walls or behind fences, which you can normally not see. Or even for firefighters, if there's people behind the fire or smoke, they could see them and go rescue them.
People hiding boats.
Yes, that too.
Could you say again just what each team member was responsible for?
Right. Tim, Jonathan, and Lance and I are actually also responsible for to design a prototype servo driver, but we ended up just scrapping that because we realized Atrium sells a servo driver that we can use.
Any other questions?
Does the Raspberry Pi have enough processing power for everything that you want to ultimately do?
Luckily, it does. In fact, when we first started doing the program, Jerry was telling us I was getting about 1 frame every 6 seconds. We were able to cut that down to about
It's running at 15 frames a second.
15 frames a second by basically just shutting down certain parts that we didn't need. But luckily, the Raspberry Pi is fast enough to process all that.